All right, today's notes, and as I do this, it's the 8th, Monday, are on distance, displacement, speed, and velocity. All right, we're going to talk about two different things when we're looking at a problem. Distance or displacement. So if I have this problem that says John walks 3 miles north, then 3 miles south. What is his distance traveled? What is his displacement? All right, so this is John. He goes 1, 2, 3 north, and then he turns around 1, 2, 3 south. So for distance traveled, he walked a total of 6 miles. Displacement, though, how far away from where he started? Well, he ended up at the same place. So displacement would be none. So displacement is and you're also going to want to put the direction. So let's say he walked 3 north and 2 south, and he ended up right there. You would say that he ended up 1 mile north from where he started. All right, now sometimes when you do these problems, they're not as easy as just counting 1 north or 2 south. So let's look at that. All right, Sonia goes 12 miles north, then 4 miles west. You need to find distance traveled and displacement. So we're always going to draw this. There's where she starts, 12 miles north. And then 4 miles west. And if you need to, you can always make a compass at the top of your paper. North, east, south, west, if that helps you keep these straight. So her distance traveled, we don't know if she was driving in a car or if she was running. We can do just 12 miles plus 4 miles. She went a total of 16 miles. But for displacement, we need to figure out this. So we know the shortest way to go from one place to another is a straight line. So she would have taken the shortest path. It would have been this. So now you should recognize this is a problem using the Pythagorean theorem from math. So if you need a little refresher on that, we'll make a little side note. When you have a 90-degree angle, A and B are the straight sides by the 90, and C is the hypotenuse, which is across from the corner. So now if I use that, and the formula is A squared plus B squared equals C squared. So this I'm just going to call A, this one B, and I'm solving for C. All right, so 12 squared plus 4 squared equals C squared. All right, so you can use a calculator. 12 times 12 is 144. 4 times 4 is 16. Now I'm going to add those together. I get 120 is C squared. I just want C. So to get rid of that, what I do to get rid of the squared is I square root both sides. So in my calculator, there's my square root, 160. I get 12.6. So I'm looking to double check my work. So 12.6 miles. And then we also have to think, what direction is that? She's going in this direction. So if I put that on my compass, that is northwest. All right, let's do another one of those. All right, I'm going to have you pause the video and try to solve this like you solved the one above and enter your answer. For distance and displacement, And did you remember to put the direction this way? And if you need to draw a compass, go ahead and draw it. Looks like southeast. All right, next up, we're going to look at the terms speed and velocity. So first, just speed. The rate an object travels at. I know you've done this before. You know speed as distance over time. And in this class, our base unit for distance is meters. So for units, meters, and usually we go meters over seconds. Be meters over second or meters per second. So a problem with speed would go like this. Find the speed of an object that goes 253 meters in 19 seconds. So every time we solve from here on out, we're going to do something called the three-step method. Let's make a note of that. So somewhere off to the side or at your heading. This is our three-step method. We use this a lot when we're solving problems with variables, like these physics problems. So the first thing I need you to do, list variables with units. That's meters, seconds, grams. Step 2, write equation. Don't put any numbers in it, just write it. You get a point for that. Okay, step 3, solve with units, box, final answer. All right, so we're going to apply that method here. Step 1, we're going to list the variables with units. So it says distance, 253 meters. Time, 19 seconds. Speed, we don't know. So now I'm going to write the equation. Speed is distance over time. Solve it. 253 meters, 19 seconds. There, I've shown my work. 13.3 meters per second. I just keep my units that I had right here. And I know you've done these in the past. The only thing new about this might be showing your work in this style. Now let's look at velocity. It is something we'll call a vector quantity, which means we have to tell what directions it's going. So it is speed with direction. So the formula then is just velocity is distance over time, but when you write your answer, you got to remember the direction it went. Let's look at an example. All right, find the velocity of an object that goes 52 meters north in 4.7 seconds. So step one, we're going to list our variables. Distance, time, velocity, I don't know. Velocity is distance over time. Just for writing that, I get a point. And it went north, so we know velocity, we must put a direction. And again, this was in meters per second. Now let's solve a problem where it's not as straightforward. Maybe you're going to solve for time or distance and they give you velocity. So we're going to find how far an object going 12.7 meters per second south goes in 5.8 seconds. So let's list our variables. It says find how far. And I like to list them in order as I read the problem. Find how far. So that's distance. I don't know. It says the velocity is 12.7 meters per second. And the time is 5.8 seconds. We know that velocity is distance over time. I like to rearrange the formula, but if you just want to plug numbers in and try to solve it, that's okay too. We are trying to solve for distance. So to get rid of time on the bottom, what I do is multiply this whole thing times time and this side by time. And when I do that, these cancel out, leaving distance over there. So I have time times velocity equals distance. And to follow my units, seconds cancels with seconds down there. I'm left with meters. And that makes sense because it said how far. And meters is a measure of distance. Now, we're not going to work through one, but I can show you what if they are solving for time. So we know velocity equals distance over time. First thing I'm going to do is get time out of the denominator by multiplying it on both sides. Next thing I'm going to do, I'm going to divide away velocity so I can get time by itself, because my goal is to get t by itself. So divide both sides by v. When I do that, it cancels out over here. And that's what I'm left with.